Welcome to Energy Talks, a regular podcast series featuring expert discussions on power system testing, data management, cybersecurity, and important trends in the power industry. My name is Scott Williams from the podcast team at OMICRON, and I will be your host. Hello, everyone. That's the sound of a normal switchgear circuit breaker open-close operation during a test, which would be expected in a real-life fault situation to protect substation assets from potential harm. However, degradation and other factors can compromise this reliable operation over time. Therefore, it is important to test and assess the condition and performance of switchgear components regularly. In this episode of Energy Talks, my guest is OMICRON product manager and switchgear testing expert, Andreas Nenning. He emphasizes the importance of testing switchgear components, such as circuit breakers, and describes the specific tests performed on various types of switchgear throughout their life cycle to ensure reliability and safety in power substations. Andreas also describes the challenges faced in testing, particularly gas-insulated switchgear, and offers helpful testing tips. Lastly, Andreas highlights future trends in switchgear testing and the advancements being made in testing technology to make switchgear testing safer, easier, and more efficient. Andreas has already been a guest along with Fred Steinhauser in Energy Talks episode 78 about the importance of working with engineering associations. So without further delay, welcome back, Andreas, to this episode of Energy Talks.
Hi, Scott. Nice to be here. Thanks for having me again.
Well, it's always nice to talk with you. Andreas, could you please describe your background with diagnostic testing on switchgear?
Yeah, it's around 12 years now. I joined OMICRON. Back then, I was product manager for the circuit breaker analyzer Sibano, which was quite new. And yeah, I was a product manager then. But over the time, I evolved in that role and become more broader, more other test devices included. And yeah, now I'm 12 years in the switchgear testing area at OMICRON.
Very good. So how is OMICRON involved in switchgear testing?
Yeah, we have plenty of test devices regarding testing of different kind of switchgears. And besides providing all those test methods, test devices, we also, as from our previous podcasts, participating in the electrical engineering societies, IEEE, SIGRE, and so on. So we are really on a broad sense here in the industry and learning from each other, from the engineers, and also contributing with new and innovative testing methods to the testing market of switchgear.
Andreas, could you describe what switchgear is and what function does it have in power substations, especially for our listeners who are not quite familiar with switchgear?
Yes. Switchgear, as the term implies, right, you are switching stuff, but a different kind of devices switching. So we have the most important one, I would say, the circuit breaker as a switching device, which breaks the circuit, separates the circuit when there's a fault on the line. But we have also disconnectors. They're also separating, but they're not capable of carrying any short circuit current. And we have grounding switches. They're also switching, but their purpose is only to ground the equipment to work there. So they're all switching, but different purpose in the grid for that.
Okay, but it sounds like they could be working together. Is that true?
Yeah, they're always a combination. So, for instance, a typical layout of a substation, you have the circuit breaker as central part when they have to extinguish any fault current or arc. But when that's done, the disconnectors getting in place, they're separating additionally the lines, the grid, to make sure it's safe to work there. And then additionally, again, the grounding comes into play and they're grounding all the stuff so you can touch everything and you're safe again. So they're kind of working together and just making sure we have a safe grid and can work there properly.
There are different types of switchgear, including low voltage and medium voltage and high voltage switchgear. There's also gas-insulated switchgear and air-insulated switchgear. What are the major differences between them?
Yeah, so besides the functionality, there's also this differentiation on the voltage level where you are. Are you in the transmission grid, high voltage grid, distribution grid? And there are different types of switchgear. They look actually totally different from each other. And within those segments, within those different voltage levels, you can still differentiate between gas-insulated and air-insulated. So yeah, switchgear worlds, you have huge variety of different designs and different purposes, basically, different applications they're serving.
Which types of switchgear are used in power substations, and when is one type selected over another?
There are different aspects to that. So one driving factor here is how much space is there. So the whole family of gas-insulated switchgear, they are used if there's not much space. They can be more compact. They have less footprint. So in high populated areas, in big cities where the property price is very high, they prefer those gas-insulated. They can be way more compact. And then, it pays off. Even though the switchgear itself, the gas-insulated switchgear, is more expensive than the air-insulated, but because they need less space and the property price is so high, they're still cheaper in the bottom line.
Why and when is it important to perform inspections and electrical testing on these different types of switchgear?
It depends a little bit on the life cycle, where you are in the life cycle of a switchgear. So you start in the factory, right? You have your factory acceptance test, and you're going to on-site, you install them, you have the commissioning. And those are basically more the functionality you are checking. You're checking, if the connection's properly done. Is somebody forgotten in there? Screwdriver or something? You want to just make sure they're working. Is the wiring correct? So they're actually switching when they're supposed to switch. So functional tests are in the beginning of the life. Then the breaker might be in service for 20, 30, 40, up to 50 years. And during that time, you want to ensure, of course, it's still working properly. You want to do the maintenance work, which, of course, is needed over such a long period of time. And therefore, the variety of tests you should or could perform. And it's basically about condition assessment. What's different conditions in there? And then towards the end, you want to know, should I invest into a new switchgear, or this one's still working? So defining this end of life towards the end. So it depends a little bit where you are in the life cycle of such a switchgear, what tests you're going to perform, and what you want to know in the end of the day.
Are there different tests performed on these types of switchgear?
Yeah, so for instance, for factory acceptance test, commissioning test, typical tests are contact resistance tests. So they're setting up, for instance, on-site, the new switchgear. They want to make sure the connections of the joints of the primary contacts are done properly. There is a certain force needed. You don't even see if it's not enough force there, but when you measure the contact resistance, you know it's going to be fine. Because circuit breakers, right, they have to carry the load when they're closed, and if there's too much resistance, they're going to heat up. So there have to be a low resistance during those periods of time. Additionally, very common on gas-insulated switchgear is to test the insulation. So when they have to install it, they might have forgotten something, some dirt inside. So it's also quite common. Actually, in combination with the voltage withstand test, they do also the partial discharge test. So those are kind of typical tests they do during commissioning of a gas-insulated circuit breaker in particular in that sense.
And why is it important to look at the insulation, especially in gas-insulated switchgear?
Because those switchgears are very compact. And the reason why that's possible to build them like that is the usually SF6 gas or the alternatives. They have very high voltage withstand, so they have a high insulation there. And you want to make sure nothing is in there to break that. For instance, any small particles or something which could cause a flashover, and then you would have connection from the primary high voltage side to the grounding and potential failure of the whole system.
Okay. Now, there is also the possibility to monitor, for example, PD activity. When does that make sense in switchgear and gas-insulated switchgear?
Particularly on gas-insulated switchgear, we see that quite often they are monitoring continuously the partial discharge. And the reason behind is, first of all, high voltage GIS is quite expensive. So they want to make sure they want to protect their investment. Additionally, of course, they want to make sure it does not fail, it's properly working. So if there are any doubts, so this breaker, this switchgear is very critical position in the grid. They spend this extra money to have this peace of mind, to ensure they're going to detect any failure in advance and they can come up with countermeasures and make sure nothing happens. So there's a kind of relationship between how much money they're going to lose if something goes wrong and how much money they're willing to spend. And this is a good example. High voltage GRS, they are usually willing or interested to have a very close look to see what's going on, and therefore typically partial discharge is their first kind of choice to monitor that, to make sure the insulation is working.
Well, thank you for that explanation. Andreas, you had mentioned voltage withstand and partial discharge testing. Are there any other tests that should be performed, or what would you consider to be the most vital tests, and when and how are they performed?
I mean, one of the basic properties, the basic purpose of a circuit breaker or switching device is the timing, how fast they're actually. So that's kind of really the basic test you're going to do. You're going to check how fast they're going to operate, how fast they're going to open. And there are different ways to do that, different challenges coming with that. And as we talked about that before, the GRS, high voltage, they're very compact. And from the testing perspective, even though such basic tests can become very complex to perform because you cannot really contact to the inner parts, to the primary parts. There are ways to do that, but it's more complex to do so. So timing test, definitely. It's a basic test about the core competence.
Okay, so that's really testing how the equipment responds. Does it respond as expected, or are there delays? Is that what you're looking for when you're talking about timing?
Exactly, yeah. So when you look at the grid as a whole, you have the protection relays. They are monitoring, they're checking, is there any fault happening? And if so, the breaker comes into play, and he's kind of the muscles of the circuit breaker is the muscle, and the relay is the brain in that sense. So he has to operate in a certain period of time, because protection is related to different levels of protection. And if they fail, another protection comes into play. So they have a certain period of time they have to operate. If not, somebody else will do it. So for instance, in a substation, you have your line going out and it's protected by a relay and a circuit breaker. And if that relay detects a fault, the breaker is supposed to operate in a certain period of time. If he's not doing that, all the other lines, or sometimes the whole bus bar gets released and operates at the same time to make sure it's not going further and escalating further. So it's very critical. It's very important. They are operating in the time they're specified for. And there's standards describing how to do that, how it's measured. The manufacturers are building and delivering those breakers according to those specifications. They're built in, and then, you have to check if they're really doing their job over the period of time, if nothing changes and they're still doing that. Therefore, you have to test frequently.
Okay, so when you're performing these frequent tests, are they performed offline or do you do them online?
It's usually safer to do them offline to get the breaker out of service and applying your test equipment than you're doing the test. And how frequently you're doing that depends a little bit, again, how important that equipment is, how important the breaker is. So if it's a very critical breaker in a very important place in the grid, you want to do it more often. For instance, I have an example here in Austria, a circuit breaker who connects a hydro generator to the grid. And if that breaker cannot connect, they cannot produce the energy and deliver it, they cannot earn money. So it's quite important to have this breaker operating. They do that every year, checking if it's properly working. But other breakers, it's not so important. There might be not so much damage. There are even extreme cases, they call that run to failure. They don't do anything until they break, and then they go there and replace them. But those are really circuit breakers that are absolutely not critical in the grid, and it does not really matter if they're operating or not.
Okay, does that mean that there is a backup there already?
Yeah. There's a backup, a parallel line, for instance. In a city, you can switch your lines and then you can come from another side to supply it from a different point in the grid. But then you need this meshed grid to do that. But not every grid is like that. You might have only a single line. Then it's more critical. You don't have alternatives. In the end of the day, it's about how much money you're going to lose if they're not operating as supposed to do. And then you decide how much money you spend on testing.
Interesting. Okay. Do you have any other testing challenges that you have experienced that you would like to tell us about?
Yeah. As I mentioned before, on GIS, as they're so compact, it's difficult to measure, even such basic timing measurements. For instance, we have a test method on the high voltage GIS who is capable of measuring the timing, even though this GIS circuit breaker is grounded on both sides. That is technically very difficult because the GIS has a very low resistance over their housing. Air-insulated switchgear, that's not such a big topic. Over the ground, there's a higher resistance, but GIS, it's very difficult. And then you need some isolating grounding switches. They're used to connect your test devices to the primary path. It's a bit more complex to set them up, but still we invented a new testing method. We call them the CSM, the current sensing measuring method, where we applying Rogowski coils over these isolating grounding switches. Then we operate the breaker, very safe, both sets grounded, and then we got the timing. So it's more effort needed on a regular air-insulated switchgear, but it's usually worth the effort as those GISs are usually the critical ones in the grid. So the people tend to spend more time to test them. And with those innovations and test methods we can provide, you have to be trained on how to do that, but in the end it pays off and gives you very reliable test results.
Okay. So you're saying that the extra effort is worth it, for example, for GIS switchgear?
Yeah, absolutely. It's a well-spent money, I would say. And we see it from the market, it is appreciated that we can support such easy and reliable test methods. And GIS, everybody expects they're going to become more important in the future as well. So we expect more need for such test methods.
Okay, well, that brings up another point. How will switchgear testing change in the future to address evolving changes in the substations, and what are the factors affecting this? For example, how will this affect testing in the future?
So when you look at the medium voltage GIS circuit breakers, we see they're very innovative. They're quickly growing market because the distribution grid is growing, driven by decentralized energy producers in this distribution grid, but also the charging infrastructure needed for electrical vehicles. So we see a high growing medium voltage distribution, and there you see all the new technology is quicker applied than on the high voltage. So for instance, we see low power instrument transformers there. They need less space than the conventional ones. We see more communication, so more digital substation coming up there. So we see a lot of changes there. And I also expect, because also the sensing devices getting smaller and smaller, that we will also see more of them in the future already built in those medium voltage GIS switchgear.
Okay, so you had mentioned before making switchgear testing easier and more reliable. How do you go about doing that? What makes switchgear testing faster, easier, and more reliable?
Basically, what we have to do as a test device manufacturer, we have to get the knowledge we have about testing, about this failure modes, about the inner workings. We have to get that into the device and make it easy to apply for our customers, basically for the tester in the field. They don't have as much time as they had before in the past. They have to set up a lot of substations in a very short period of time. They have to be quick, but they still need to be reliable and safe. So yeah, therefore, we're working on providing proper test devices to make it more efficient. Basically moving that knowledge we have about testing into the test devices and keeping the tester away from those fuzzy small things. Just keep it simple, but still reliable and safe.
Do you have any practical advice for making switchgear testing more efficient?
Yeah, I mean, learning, training, and joining those SIGRE and IEEE associations, because that's the way I got into that industry. you learn a lot, you share your experience with them, you can maybe discuss some cases you're not sure about. Along the way, you learn a lot. And in the end of the day, it's about understanding what you're doing and why you're doing that. And of course, the obvious answer for your question is using our great devices, of course.
Very good. Now, again, in the devices, you pack a lot of experience and customer feedback into the devices to help users work efficiently, safer, and quicker. What are some of those features? Are we talking about automated workflows or an automated way of collecting and analyzing data? What's involved there?
Yeah, it's a combination of all of that, because the bottom line is the customer wants to do the tests fast, reliable, and the results, they have to be scientifically proven, they have to be right. So for instance, on the medium voltage test device Sibano, we implemented a test method. It's called the VTM, the voltage-based timing test. And it's basically a feedback we got from the market that you can use a very easy connection point on those medium voltage circuit breakers. It's called the VDS detection system, capacity coupled connection to the primary path. So you can measure the voltage on the primary over these secondary contacts. You have around 10 to 30 volts. And then you have the contacts of the breaker, and then you can do your timing test. Very easy connections done. And then in the test device itself, you want to have a very easy to follow guidance workflow. So it's important to make that as easy as possible. You do perform the test quickly. Then after that, the report generation should be in there. And further on, you need some synchronization to the cloud, to the grid. So the whole experience for the customer needs to be as efficient and short and easy to understand and learn as possible. And we are able to do that because we have feedback from the market. We have good relationships to our customers. So we are constantly discussing and improving our test equipment.
Andreas, where can our listeners get more information about switchgear testing at OMICRON? Which knowledge-sharing tools are available?
I would recommend going to our website, omicronenergy.com, and there we have the OMICRON Solution Finder. It guides you through your testing requirements. So, for instance, what breakers do I have? You got additional information about what type of breakers are there. Next step, you can define what tests are there, what can I use, again, with some additional descriptions. So for those who are not familiar with those tests, they can get an insight what's going on, so what we can provide for them. But they also learn about methods which are available or switchgear which they might not have known so far. So those things you can find on our omicronenergy.com page /CPQ or searching for the Solution Finder. And then you get more information, not only about OMICRON products, it's also about the whole switchgear testing industry.
Yeah, so under applications, you can actually see which tests are recommended for high voltage and medium voltage switchgear, for gas-insulated and air-insulated switchgear. It offers a lot of information about each test. The other thing is, training, you say, is very important. Our OMICRON Academy offers training in different areas of power system testing. Does that also include circuit breaker testing?
Yeah, we have, particularly in our location here in Austria, we just recently got new equipment, new breakers, and we do the trainings there. People can just book their academy courses and have hands-on information and trainings on how to do the tests with our test equipment.
Well, thank you, Andreas, for joining me for this Energy Talks episode about switchgear testing.
Oh, Scott, it was a pleasure, like always. Thank you for having me.
And a big thank you to our audience for listening to this and other episodes of Energy Talks. We always welcome your questions and feedback. Please send us an email to podcast@omicronenergy.com. OMICRON has several years of experience in power system testing, data management, and cybersecurity, and offers a matching solution for your application. For more information, visit our website at omicronenergy.com. Please join us for the next episode of Energy Talks. Goodbye for now, everyone.